tissue covering. Okay? If y'all look at the handout that I gave you, all right? The hierarchy of the skeletal muscle. And y'all can see I had to like make mine one slide per page. Because after I printed off the 2 slides, I'm sitting there and I'm going, and then I'm like, whoa, hold on. So I had to go back and print 1 per page for me, and I still need these. Okay? Now, this hierarchy, we're going to see that we have connective tissue wrapping. We've got epi, peri, endo. We've got outer, middle, inner. Now, what this allows for when you hear the word muscle, does anything come to mind? A particular muscle, maybe? The quad, okay. Ham, glute, delt, pec, ab, right? Right. Okay? That's what we tend to think about. Because that is a muscle. All right? That muscle use this one. It's easy. It's the longest muscle in the body. It's the sartorius. Okay? This is a muscle enclosed in my epimysium. This means that this muscle right here has the connective tissue wrapping all the way around it. However, this muscle is going to be made up of fascicles. Now, look at the handout, okay? It's trying to show me in this first level of the hierarchy, the muscle as a whole, wrapped in the epimysium. Does everybody see that? Okay? That muscle is going to be made up of all these fibers, aka cells. However, those cells that are making this up, okay, if I look at this like cut through this muscle right here, these cells would be in groups. And that grouping is called a fascicle. And so I would have group after group after group after group after group. Okay, everybody with me? And let's say per group there are 10 cells, aka fibers. All right? So out of this muscle, for every 10, it's wrapped in my perimysium. You guys see that right there? Okay? Now, if I take that one fascicle, let's say those 10 fibers, all right? Those fibers, that cell, is composed of these myofibrils. The third picture.
You said the perimysium is covered around each fascicle, you said?
It'll be around a group, and a group is a fascicle. All right? And if I take that one fascicle and break it down into each individual cell, like if I had 10 fibers in there, and And if I begin to look at every single fiber, all right, that's what makes muscle contract. At the level of that one muscle cell, the activities that occur are going to determine if a muscle contraction takes place. Now, let that sink in for a second. I just said it is up to one single fiber, one cell. The reason for that is because of the structure found within that fiber. And those are going to be my protein filaments, my actin and my myosin. All right? So, if I take this muscle that's wrapped in epi, okay, which would be attached to a bone, and if I were to take this and begin to make a cross section through it and look down on it like this, I'm going to start breaking it apart into an individual muscle cell. So, this picture has done that for me. Now, in this picture, where I've got my huge muscle, is there anything from this muscle as a whole that you notice? Do you notice that it has one artery, one vein, and one nerve? Every muscle of the body is like this. It will have a major nerve that enters that muscle, okay? And it will have its blood supply. Now, if I begin to look at my cross-sectional cut, and I look at it, start breaking it down, this muscle, which is made up of muscle fibers, and fibers together in a group create what's called a fascicle, which is wrapped by the connective tissue wrapping, perimysium, okay? If I begin to look, this group of fibers, fascicle, this one, group fibers, group of 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 fibers, group of, y'all see where I'm going with that one? All right, so these groups of fibers that have their own connective tissue wrapping, what do you notice about them? I just told you. Zach?
They all have arteries.
They have an artery, a vein, and a nerve. So that tells me from the point of entry of the big muscle, it began to branch. So now, at every single one of these groups, okay, this group, this fascicle, artery, vein, nerve, artery, vein, nerve, artery, vein, nerve. Is everybody with me? Okay? If I take one of these fascicles, okay, and I begin to look at the makeup of the muscle cell, okay, am I to that page yet? Not yet, okay? So look at the connection to this, and I'm still not at the slide that I want. Hold on. There we go. So I have my big muscle, I have my fascicles, I have a muscle cell, aka fiber, which is made up of protein filaments. Does everybody see that? Okay? So, and what do you notice at every single breaking down? We still have blood, we still have nerve. So I have now just told you that for every big muscle in your body, it has one big nerve that comes into it. And then it begins to branch. And as that branching occurs, it branches to meet every single cell, every single fiber. All right? Now, it is going to be dependent on the stimulus that muscle receives and the strength of it as to whether that muscle is going to contract. Now, here's something that is going to be a little confusing until you get to part 2. Neuron, of course, means nerve, okay? And for muscle movement, as that nerve comes into the muscle, as it branches, as it meets every fiber, every cell, it's being innervated by a motor neuron. Now, what does that mean? Sort of, but maybe. I know, right? Okay. So here's what has to happen. Because I'm talking about my skeletal muscle, for the most part, okay, is going to respond because of higher order thinking. As you sit here right now, you're thinking 3:15, she's going to say, take a break, be back at 3:30, somewhere up here in the frontal region of the brain, getting to other areas of the brain that I won't get into right now, okay? It's going, come on, okay? It's doing that, all right? Now, what's going to happen, because this is already thinking about it, the muscles that are going to be needed to make your movement possible, meaning to get up out of the chair and walk or whatever you're going to do, okay, they are already receiving